Hi everyone, welcome to my channel. Today I'm going to give you a quick walkthrough of a production style banking platform I built and deployed on Amazon EKS. The platform consists of 30 Go microservices, a React frontend, API gateway, Kafka, PostgreSQL, Redis, and a double entry ledger. From the DevOps side, I implemented AWS, infrastructure with Terraform, GitLab CI/CD, Docker, Amazon ECR, Kubernetes, Helm, and Argo CD, along with a complete observability stack. Okay, this is my architecture. So once developer push code to GitLab, the GitLab CI builds the microservices, runs security scanning with Traefik, builds the Docker images, and pushes them to Amazon ECR. Then the pipeline updates the image tags in the GitOps repository. Argo CD detects that change and automatically deploys the new version to the EKS cluster. So the deployment process is completely GitOps driven. Now let's see the application running on the cluster. So this is my application here. Okay, let me try to log in. So I'm logged in already. Okay, I have an account already. So let me just log in with that account. So I've successfully logged in. So this is the React frontend running on the Kubernetes behind the ingress. Okay, this is my dashboard. This is the account, deposits, transfer, cards, loans, and I can also log out from here. So let me just test run the application. Let me try to deposit. I have an account. An account created already. So let me just deposit. So okay, let me try euro. So you can see deposit posted 200 euro. Okay. Now let me walk you through the pipeline. So this is the pipeline here. So basically, once code changes are made in any of the services, front end, PKG, Proto, builds, deploy Elm or GitLab file, the pipeline is automatically triggered. A new Go microservices image are being built, Traefik run vulnerability scanning, the images are being pushed to Amazon ECR, then a new tags of image is updated to the repository, then Argo CD detect these new changes and update them to the cluster. Now let's try to make change to the repository. So let's see our pipeline run in action. So I'll just make minor change to this repository. So let me just do the changes from here. Okay, let me just do this. Okay. So now you can see our pipeline. Our pipeline is running. This automatically triggered the pipeline. Now let's see our pipeline running. So you can see our pipeline running. So you can see 30 microservices are running in parallel, are being built per image. Okay, let's wait for our pipeline to complete its build stage. So you can see we have some images built already. So let's just check one of the images that has been built. Okay, you see it. So you can see the pipeline. This is our image that is being built. You can see Traefik. This is Traefik scan. So you can see Traefik scan. Traefik scan is for vulnerability scanning. So you can see so our image got built and pushed successfully. Now let's wait for the other images. Some images are still being built. So our pipeline is still running. So let's just give it a few moments for it to run completely. Okay. Now you can see almost all our images build has been completed. Okay. So so you can see our pipeline run successfully. It successfully updated the image tags. Now let's see the CD. Let's see our deployment. So Argo CD handles deployment. So Argo CD detects the git change and automatically synchronize the application with the EKS cluster. So this is the Argo CD banking platform. So let's synchronize this. So you see the pod changes now. So you can see new pods are being created, old pods are being deleted. So you can see our new image tags has been updated in the CD pipeline. So you can see our new image tags. So you can see it. So it takes a few time. So you can see Argo CD successfully synchronize our new image tags deployment to the cluster. So you can see all the pods are LD. So you can see it. We have succeeded few minutes ago. Succeeded 2 minutes ago. So let's refresh our application. So you can see our application. So the application is still running. So you can see, despite the code changes, our application is still running fine. You can see our new image tags. So you can see they are all running, all our pods are LD. So you can see them here. So you can see all our pods are LD. Now let's check the observability stack. So once the application is running, observability is extremely important. So I'm using Prometheus for metrics, Loki for logs, and Tempo for distributed tracing, all visualized through Grafana. So this is my Grafana here. This is the dashboard. So you can see the dashboard per services. Let's check per services. So you can see each services here. So this is the Loki for log, centralized logging. So you can see the Grafana dashboard. So we have memory, usage per pod, request rates. So you can see per services. Let's check for front end. You can see. Okay. Now the infrastructure. This is my infrastructure here. Okay. Okay. This is the infrastructure. So the AWS infrastructure was provisioned using Terraform, including the VPC, EKS cluster, IAM, ECR, S3, and supporting services. Applications are packaged using M and deployed using Argo CD. Now let's see, we also have Prometheus for metrics collection. Let's try to query some metrics. I have them here. This is the observability. Let's try to query some metrics. So we can check total request per services. So let's try to make, so you can see total request per services that we have. You can see for account services we have 107 requests. So you can see the Prometheus queries. Let's query another. You can also query error rate per service. Let's check if there are any errors. You see there is no error. So that means all our applications are running well and fine. Okay, I think that's all for this. We also have alert manager for setting alerts. So that's all for this project. Overall, this project allowed me to bring together AWS, Terraform, Kubernetes, GitLab CI/CD, Docker, GitOps, observability, security, and automation into one end-to-end platform. The goal wasn't just to deploy an application, but to demonstrate how a DevOps team can build, secure, deploy, monitor, and continuously deliver applications on Kubernetes. So thanks for watching. This repository is linked below if you would like to explore the implementation. So that's all for this demo.